Hey everyone, it's me, Miss B, and in this video we're looking at the Unit 6 Lesson 9 cumulative practice problems, and this is for illustrative math geometry. So today's lesson was all about point slope form and basically ways to write equations of lines, and it tied in a bit to the way we write equations of circles. We kind of write stuff with h comma k. So we have some standard forms here. And we have some slope-intercept forms here, but then D and E, these are both on this first one, what we call point slope form. So I'm going to actually just add the generic or the general version of point slope form up on the top here. So just so that I have it, and just so that you can see what it is. So we'll say point slope form. And that is going to be y minus k equal to m times x minus h. And this is where m is the slope and h comma k is just a point that it passes through. Does not have to be an intercept or anything like that. So that's why this is useful, because we don't need an intercept in order to do this one like we would need with slope-intercept form. So we want to select all equations that represent this graph. Let's look at our slope-intercept forms first. I think this one here with the -3 intercept is going to represent it here because we have a -3 on our intercept. And then it does show a slope of 3 over 2, which this one looks like it goes up 1, 2, 3, and then over 1, 2. So I would say, yeah, for this first one, I would definitely say that C is one of our answers, but it does select all, so we're going to have more than one here. And we can even check using intercepts. So it might be a little bit of a throwback, but to check using x and y intercepts, the easiest form to use is going to be this one right here, which is standard form. And to do that, you plug in 0. So when you plug in 0 for x, that's going to give you the y-intercept. So we would say, oh, plug in 0, that's going to be -2y is equal to 6. And this would help us find our intercept, which would be the y-intercept of -3. And then likewise, if we plugged in 0 instead for y, we would end up with 3x equal to 6. And that would give us the x value of 2, so +2 comma 0. And these are easiest to get by plugging in 0 here. I'm doing that lately, pulling up my highlighter instead of my eraser. And so, because those do look to be the correct intercepts here, +2 on the x-axis and -3 on the y, I'm going to say that this one is also a correct answer. Now, B and C have the same slope but different intercepts, so it's not possible for them to both be answers. So since C does work, we're going to get rid of B. And then we're going to check these numbers down here. So this here shows 3 over 2, which is in our M position, but it's good because that's our slope. But we want to check if the points that they're pointing out or saying that it passes through actually work. So this one here is saying that we have the point +4, +3, and the one below it is saying that we have +2, +6. So we're going to check both of those. Is 4 comma 3, so over to 4, up 1, 2, 3. That one is on the line, so I would say yes, it is. And then 2 comma 6 is the other one. That would be 2. This is 2 comma 0, so it does not work. So that means that D is a solution, or not a solution. It's a solution to this question, but D is an equation that represents it, and E is not. And that's just the first question. Now, we want to look at a couple things here. On this next one, they're telling us about a line with a slope and passing through a specific point. I'm going to use that to write an equation here. So point slope form is great because it tells us the relationship between any point, which we can plug those values in for x and y. And then if it works, it's designed to make it with a slope and the point that we are given. Sorry, that was a jumbled mess of an explanation. It's designed to check, is the slope between those 2 points the intended slope? So let's actually just write point slope form of this one here. We would say y minus 3 is equal to 3 over 2 times x minus 1. And this is the equation we would use in point slope form. Now, what we can do in order to check is plug in these values and see that they actually make it true. So if I need to explain why 3 comma 6 is on the line, plugging in those values for x and for y is going to be part of my explanation. So 3 gets plugged in for x and 6 gets plugged in for y. So let's start with this. Instead of y, it's going to be 6 minus 3 equal to 3 over 2 times 3 minus 1. And so let's work this out, and we want to see if this is balanced. And if the sides are balanced, that means it's going to be on the line. Now they did say explain why it's on the line, not asking if, so I'm pretty sure this is supposed to work out. So 6 minus 3 on the left over here, that's pretty straightforward. 6 minus 3 is 3. But on the right, we're going to have 3 over 2, and then 3 minus 1 is 2. The nice thing here is that 2 and 2 here will kind of cancel each other out, and we'll end up with 3 equals 3. So I might say here, the point is on the line because it has a slope of 3 over 2 with 0.1 comma 3. This is what that equation actually checks. So that equation is designed to give a result for any point that actually makes a specific slope with the input point. And so by plugging it in and the equation being true, that means the point is on the line, and that's because it creates the slope of 3 over 2 with 0.1 comma 3. Now, the same reason for 0, 0 would apply for it to not be on the line, because it would not make that same slope, and we would be able to see that by it not making the equation true. I'm going to add a little note down here, like if, no, not a note, a little like side thing here, basically saying it makes the equation true. And making the equation true is what gives us that result, or that description of it being on the line, making that slope. So let's explain why 0, 0 is not on this line. And we're going to do that by plugging in. So we're going to have 0, we'll do blue here, minus 3 equal to 3 over 2 times 0 minus 1. And then this is going to be negative 3 equal to 3 over 2 times negative 1. Negative 3, this is not going to be equal to negative 3 over 2. So I'm going to say the point is not on the line because it does not make the equation true meaning it does not make a slope of 3/2 with point 1 comma 3. So it doesn't make the equation true, which means that it does not make that slope with the point that we wanted. Now for C, we got to solve it first. Not going to be quite sure whether or not it's going to be on the line because they don't tell us, but we're going to do that the same way. So we're going to start with 13. I'm sorry, not 13. This is y minus x. So I need to do 20, not y minus x, y minus k. 22 is going to be minus 3, and then 3/2, and then here we should have 13 minus 1. So let's work this one out. 22 minus 3, 21, 20, 19, that should be, yeah, 19. And that's going to be equal to 3/2, and then 13 minus 1 is 12. So here we're going to do, I mean, you can use a calculator to figure this out, 3/2 times 12, but just in case you'd rather not, you can do either part first, the division or the multiplication, but 3/2 means you're going to take the number, in this case 12, multiply it by 3, and divide it by 2. Um, a lot of times I like to reduce if possible first and then multiply, but you can do it in either order. Basically, if I take 12, divide it by 2, that's going to give me 6, and then multiply it by 3, that would give me 18. I like to do the division first if possible because smaller numbers are easier to then multiply together, especially if I don't have a calculator on hand. Now this makes 18, which means 19 is not equal to 18. So we can say the point is not on the line. Because, and we'll just say the thing about the slope, not about making the equation true. We can say because it does not make a slope of 3/2 with point 1 comma 3. There we go. All right. So that's it for question 2. Was it still 1 comma 3? Yeah, it's 1 comma 3. It just happens to also be 1 comma 3 in this next question, which is why I was questioning myself a little bit. So you'll notice we're skipping 4, 5, and 6. We're just doing question 3 here. And this one's not going to be so bad either. We're going to start, well, I'll just start with my general form. Y minus k is going to be equal to m times x minus h. Now, if you want, you can go through and identify here that h is going to be 1, k is going to be 3, and then m is 5/4. That means when we plug this all in, we will have y minus 3 equals 5/4 times x minus 1. And this is the answer. And that's it for the front side of the page, and that's going to be most of the newest stuff. Generally, the back side is just some review, so let's flip on over to the back and do the review. Here, question 7, we have circles. Okay, so it is slightly review, but it's from pretty recent stuff. So select the center of the circle represented by the equation x squared plus y squared minus 8x plus 11y minus 2 equals 0, and be sure to show all of your work. So if we want to show all of our work, that means we're going to be completing the square a couple times here. And then I have some different numbers there. It looks like a couple of them are 4s and negative 5.5s. So something tells me it might be those, because 8 and 11 stands out a little bit from that whole group, but you never know. So let's just do this work here first. Pretty much, I need to swap positions of these two pieces. And I'm also going to take this negative 2 and move it to the other side of my equation. I'm going to move it to the other side of the equation by addition. So if you're comfortable with adding 2 to both sides, that's what I'm doing. But I also sometimes like to think that I'm just jumping it over the equal sign here, and when it changes signs, or I'm sorry, when it changes sides, then it changes signs. So that type of thing works as well. So when I move these two pieces and I kind of swap their positions, I'm making sure that the negative stays with the 8x and the positive stays with the y squared. And then I'm actually going to write some room here into each of these. So you'll see that I'm doing a couple of things all at once in this first step, but I'll make sure I explain each piece. So we'll have x squared, and then I'm going to have the minus 8x because it's trading positions with y. I'm going to leave myself space, but it's going to be plus a blank space. Then I'm going to write that plus y squared. And next comes plus 11y. I'm also going to leave myself a blank space here because we're going to make each of these into perfect square trinomials. And if we do that, we have to make sure that both sides are balanced. So we have the positive 2 on the right-hand side. Since it was negative to begin with, I don't know why I erased that circle. We are moving it over. I just wanted to remove the little like line I drew in between. So we're going to also have to add our other spaces here for things that we're adding on. So I am getting a little close to the edge of my document here, which means I might scoot some of this over a little bit because I wasn't trying to go off the edge. There we go. Now, what I think is easiest is actually to create on the next line below the formats here for your factored versions, because ideally we're creating these two squared binomials and then have it be equal to something. Because having these here first makes it a little bit easier to do this next part. We know that we're going to have x in here, but there's a central sort of step here. We're going to divide this middle term by 2, and that number goes down in here. So that's going to be minus 4. And when we square that number, that's what will come back here. So 4 squared is 16. And I did say we're dividing by 2, but we're also dropping the x off of the side of that negative 8x. We're going to do the same process on the right-hand side over here, or on the y factorization part. So we'll have y here. Then this 11 is going to get divided by 2. This looks like where the 5.5 stuff comes in. And so here we end up, well, 11 divided by 2 is 5.5. So we're going to say plus 5.5. And 5.5 squared is going to be an interesting number, but we don't actually need to find the radius, because here they're just asking us to actually find the center. So this number is going to be 30.25, just in case you want to know. So these would be 16 and 30.25. When we add up the right-hand side all together, we'd have 16 plus 2 plus 30.25, and this is going to be 48.25. So all of these added together, 48.25. Now, the center is the only part that matters. So it says select the center. That means our center is going to be built off of this -4 and the positive 5.5. However, our signs should be different. So the center should be +4 and -5.5. And that one here, option D. And remember, that's because the standard form, or this form of our circle here, is x minus h squared. And our values here are just the positive version of h and the positive version of k. So we change our signs. That's going to bring us then down to the last question, which is to just do some transformations here. So first we have reflecting this triangle over the line x equals -6. So right away, I can tell you this is going to be a horizontal line. Not horizontal, wow. X goes horizontal, so this is going to be a vertical line. That was definitely misspeaking there. So we're going to find -6 on the x-axis right here, and we are going to draw a line straight through it. This is the line we're going to reflect across. Let me see if I can move this down a little bit. There we go. So we're going to reflect across this, and then we're going to translate. So I'm going to do the reflection part first, and then we'll do the translation. So reflection first. We'll do this one in blue, I think. So reflecting across, that means A prime is going to land here. C prime will land here. And B prime is going to be in the same spot because it will not move since it's on the line of reflection. So that's my first triangle. Now I'm going to take this line segment and we're going to translate the image. And this is by a specific directed line segment. So we're going to interpret what this means right here. If it goes from 0, 0 to 5, -1, this means we're adding 5 and subtracting 1. So on the x-axis, adding 5 is right 5, and on the y-axis, subtracting 1 is down 1. And you could even draw in here from 0, 0 to 1, 2, 3, 4, 5, -1. You could even draw a directed line segment here and then kind of measure it up afterwards. I'll probably show you that, guys, because I get to actually like pick it up and kind of float it around. But let's take our individual points and just apply that idea. So from this point here, we're going to go to the right 5 and down 1. So 1, 2, 3, 4, 5, down 1 is going to place us there. Actually, I'm going to erase this just so that it's not in my way. You know what? Because I am going to use it later, so let's move this to the side and kind of just keep it waiting. It just looked like it was going to be in the way of my current points that I'm trying to plot. So this one here, this is now going to be B double prime. Then from C prime, we want to go 1, 2, 3, 4, 5, and down 1. C double prime is going to land right here. And then A double prime, 1, 2, 3, 4, 5, and down 1. A double prime lands here. And yeah, this would be right up next to our directed line segment, so I didn't want to make that too crazy. Oh, and you might notice what I did. I did something wrong because my triangle doesn't look quite right. C and B look accurate based on this. They look like the same distance apart and the same thing, but A is definitely out of place. So what I did wrong was I didn't use the correct triangle. I was using this point for A. I want to start here, go 1, 2, 3, 4, 5, and down 1. My point's going to end up right here, and then my triangle's going to look a lot better. Much better. Much better. Okay, this looks like the right thing. So, this should be my newest triangle, and it wanted to know what are the coordinates of the vertices. So I can also double check, like, hey, is this right? By picking up my directed line segment here and seeing if my beginning and end line up with each of these pieces, and they do. So I'm going to get rid of this guy now because I don't need it. And we're going to write out what these are. So my A double prime, or the new coordinate of A, this looks like it is -2, +1. My new coordinates for B, in this case B double prime, is -1, -2. And our new coordinates for C are -4, -1. These are your answers. Now I guess I'll move them so they're a little easier to read, and I'll place them over here so that they're actually against the white background instead of the graph one. But yeah, that's the last question. So hopefully that wasn't too troublesome, and hopefully you didn't make that mistake like I did. And if you did make a mistake, hopefully you caught it. Um, but if you have any questions, always be sure to ask in class. And thanks for watching. This has been the Unit 6, Lesson 9, Cumulative Practice Problems for Illustrative Math Geometry.